So you should be seeing something now in Connect. Great. I have a little bit of a wonky setup on this in this lecture room, so I will probably be running a bit back and forth because I can't see the chat really. Anyway, we should start with the peer review stuff. As you probably have noticed, the peer review instructions have been updated, and you should be able to check it out. And there is a step-for-step guide here. Maybe the most important thing to notice is that, well, if you wrote in English, you should check the English tab in the sheet, or if you wrote in Swedish, you should check the Swedish sheet in this spreadsheet. And that you are to review the next 2 groups in the list. So, next 2 groups after your group, those are the ones you should take a look at. And if you are the last group or the second last group, you start at the top. So the last group reviews the 2 top groups. And you should find the link to the materials you should take a look at, and the contact person also that you should email your reviews to in this sheet. So maybe we should just take a look at it and see that. Seems to be okay. So you find your group here. Default is English. Most of you were here. So this group, number 11, should review the 12 and 13. And you should be able to find the material, a link to the materials here. So hopefully that is not a problem, and if you wrote in Swedish, you should click the Swedish tab, and well, you should probably find yourself here also. Some questions on the on Slack. I've not had time to check it out today, but yesterday evening were about references, and looking at the instructions, you should have references in your peer reviews. This is new for this year, but try to find some references to motivate your opinions. Because if you just say, we think that this is good or bad, well, yes, you may think that, but who says that you are right? So try to find, for example, parts in the course literature that says something similar, so that the group that receives your feedback can go and take a look at it. Because if it's just an opinion, it's really, really easy to just, well, that's just an opinion, and throw that opinion away. And you are of course free to reference things outside of the book. So you are encouraged to find sources, other sources also. There is always a question about high quality sources or not. And of course you should strive to get high quality sources. Anyone knows what a high quality source of information is? No one? So, for example, my lectures, are they a good quality source?
No.
Exactly. Why? So my lectures are probably not a good quality source to reference, at least. Why are my lectures not a good source to reference? Basically, it's because it's second-hand information. You get my opinion of the book on the lectures. That is my experiences, and my worldview colors my interpretation of what he says in the book, and I may exaggerate, I may do things to provide a pedagogical point of view, and things like that. I can misunderstand also, of course. So one thing to look out for is secondhand information. And for example, Wikipedia is a great source of information, but Wikipedia is at best secondhand information. So if we take a look at Wikipedia, I'm not done this. Let's just search domain model. So first of all, they have this warning. They don't have any sites or references or sources. So everything you see here is just the author's opinion. And of course, it's probably a few authors, maybe, but you should really go to the notes here. Or if they have references, and to external links and check them out. What are these sources of information? So Wikipedia can be a really, really great start, but that is also secondhand information. So you need to go to find the source of the information. And this is also the case even if you find a good quality journal in computer science or peer-reviewed papers from scientific sources. You also need to check the references they have, because otherwise it becomes kind of like the whispering game. You can read that this and this author said that, the other author said that, and that is not a good idea. Because people misinterpret. And the longer the chain is from the source, well, you all know the whispering game. It's suddenly it's not at all what the author meant. So try to find the root sources, so to speak. I also think that in the book he has some references, so that is also something that you can check out. So I encourage you to look beyond the book. The book is good and fine, but well, you can take it a step further if you would like to. And of course, any reference is better than no reference, even if it's a low quality reference. But that should also be taken into consideration maybe when you write your opinion that, well, this was just some dude's blog. And maybe he wrote good stuff, but well, it's just some dude's blog anyway. And of course, if you can find multiple sources that says the same thing, that is even better. So if you can list a whole number of sources, of good quality sources that says the same thing, well, then maybe you have found something that is, well, this is some kind of consensus about this topic. And that is always a good thing. It's an accepted, more or less, fact. All right. Focus on original references. And otherwise, you have the instructions here. Check the model. Go through the steps of this and write down what you think, reference if others think the same thing, and then you email this to, you save the peer review protocols and you email it to the course, the group responsible for that review. And this should be done no later than tomorrow, 12 o'clock. And then there will be a new form here. So when this deadline has passed, you fill in this form and say, well, we have sent our reviews to this group and to that group, and we have received reviews from this group and that group. If you do not receive anything, well, then you can fill that part in. So basically, I want to know that you have sent your reviews and that you have received your reviews. So yes, sometime after the deadline, you will send that form. Maybe you can wait for like 3 or 4 hours. You never know with email. Any questions on the peer review stuff? Last year I did not use this form of telling you who to review. I sent a bunch of emails. That was really tedious and error prone, so I hope this will work a little bit better. Yeah, okay. Feel free to ask questions on the lecture or in Slack, and I will try to answer them as fast as possible. Best is of course, if you have questions now. But that said, let's move on. Yesterday we talked a bit about design patterns. Do you remember what a design pattern is? Anyone? A software pattern? Do you remember anything about software patterns? It's like 23 hours ago. They have a name? Yeah?
Model view.
Yeah, that is one principle at least, model view separation principle. It is not exactly a pattern. We will talk more about model view controller that is a pattern today. But the important thing to remember about patterns is that they have a name. This is good for discussion. And we can write down the name and say, okay, we are going to solve this by using the builder pattern instead of writing a complicated diagram. So the name is important. And another important aspect is that it is an abstract problem that is described with an abstract solution. So your job as when using patterns is to take your specific problem and find the matching abstract problems. This is not often an easy task because you are so involved in your specific problem. It is hard to imagine the abstract problem. And then you take a look at the abstract solution, and then you apply this abstract solution in your specific context. So that is basically the work. And this also means that it is good to have a broad knowledge about patterns. And there are many, many patterns for design. And one risk is that you learn kind of like a few patterns, and then you apply them to everything. And that is probably not a good thing. So if you own a hammer, everything turns out to be nails, and you use a hammer for everything. But you really need to have many tools in your box. And the way to get this is, of course, to study. And the first book, at least as far as I know, is this book, Design Patterns, Elements of Reusable Object-Oriented Software. In this book, they presented the idea of design patterns. And there was this four guys, Gamma, Helm, Johnson, and Blisides, that did this. And they have consequently been named the Gang of Four. And you also have this reference in the book, the Gang of Four patterns, the GOF patterns. And they wrote this book inspired by patterns in buildings actually. So there was an architect called Christoph Alexander that saw that, oh, we have similar problems in many buildings, so we can apply similar solutions to these. And so they have patterns in architecture, building architecture also. And he wrote a book, and these guys read this book and they saw that, well, we have worked on many projects, and we have seen problems come up again and again and again and again, the same type of problems, and we have applied the same types of solutions over and over and over. And well, this maybe should be some kind of knowledge that is written down. And they applied the pattern idea to this, and the result was this book. I have it here also with me, so if you want to take a look at it during the break, you can. I highly recommend it. It takes up something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some 20 plus patterns. So you can check it out. You can probably find it online. It's very popular. So I recommend it. Buy it, read it, live with it. Another book in the pattern realm is this, Pattern-Oriented Software Architecture. Also really good. Patterns on the architectural level. So in this book you find, for example, model view controller that we're going to speak about a little bit more about today. You find patterns like layers and well, a lot of patterns for building applications on the architectural level. Maybe this is even more important, because when you learn an architectural pattern or a style, you tend to apply this to everything. So maybe you're really focused on web development, and model view controller is quite popular there, and suddenly everything needs to be model view controller. And well, it's a good pattern, but there are others. So don't just be the guy that knows the hammer. You should know more than just the hammer. So there is no such thing as the ultimate pattern that will solve every bit of your problems. You can take a look at this book also if you want to. I have it here. So, okay, we have a question coming up. Are there specific chapters to read? Well, I think in both these books they deserve to be read from the start to the finish. Maybe not all at once, but you can of course you can find, for example, the patterns that we are looking at in this course. You can find these in these books, and you can get another point of view. Probably some deeper and more information, and another example of implementation. And that is always good. For example, in this pattern-oriented software architecture, you can read about the model view controller pattern. And you can find references to where it comes from and things like that. And there are a lot of design pattern books. Maybe we should list. There are usually some people also bought this and stuff like that. So you can just see how many design pattern books there are. design patterns? Well, as you can see, there are lots of design patterns. Some are more or less technology or language specific, some are more generic. Something probably has not anything at all to do with software in this. So, well, take a look at these two books. Those are the ones that I recommend as the basic books about software patterns.
Will you link them?
I can put some links up on and the ISBN numbers and stuff like that, so you can find it on the course homepage. I will also change this to lecture number 4 as we go along. So let's get started. I don't have any fancy slides today, or colorful slides at least. But basically, we're going to talk about the model view controller architectural pattern today. And as far as I know, at least some of you recognize this pattern already. Model view controller. Forgot the dash, but and it does not seem to be any good way of editing, so we will have to live with it. The first thing in a pattern, the name, model view controller. The second thing is some kind of problem description. What kinds of problems does this pattern solve? Do you know why we use the model view controller pattern? I know some of you have at least had some information about it. What are the problems we're going to solve? Separate view from logic, and yeah, that is actually the solution to the problem. We want to have separate view and logic. So, but why do we want to have that? For them to be interchangeable. So, yeah, and why do we want them to be interchangeable? Reusability, for example. So we want to reuse parts of the system, and we probably want other types of user interfaces when we do this. Exactly as we saw this circle example yesterday. We made this kind of like monolithic circle, and it turned out to be hard to reuse because we added a lot of information and functions that had nothing to do with the actual calculation of the radius, but rather with the user interface. Yes. Use the same model and controller on the same iOS, Android, etc. And the problem we want to address there is so we have, at least in multi-user systems, we have different types of users. You maybe have expert users. They want one type of interface. They want a command line because that's much quicker for them. You have beginner users. They want a really step-by-step graphical user interface with 2 buttons to click in every step so that they don't mess up. And maybe we have intermediate users also that, well, they want a graphical user interface, but it can be quite complicated and they want access to all functionality. We also have different needs in different situations. If I'm traveling, well, I would like to access this system using my phone. And there we have a radically different paradigm of interaction. We don't have keyboard anymore. We have a point and click interface instead. And depending on the type of, maybe I have this gigantic Wacom. That is quite different user interface from this, even though they are both point and click. So we have different needs for different people in different situations. Anything else?
Scalability.
Scalability. What do you mean with scalability?
That the application can grow and get bigger without too much.
That is not one of the classic problems, at least, but I will write it down. We'll put it like this. That is maybe more of a consequence, that you can get scalability by using the model view controller pattern. Well, as we said yesterday, we have a bunch of different technologies for user interfaces, quite complicated technologies. They always change, they evolve. We get new kinds of devices, new types of interaction. So we have a technology that pushes on the system, and we want often to be competitive, and well, then maybe you need to stay on this bleeding edge of interfaces. Users also have different needs over time. Well, my need right now is this, but later on we have other needs. You may have a situation where you have the same information or same functionality, but it should be presented in different ways. The classic example is to have, imagine a spreadsheet. You have a table with numbers. That is one type of information display. You can also make different types of diagrams for this. You can make a pie chart. You can make a bar chart. And they can like show the same information in different ways. Changes should be presented immediately. So we have changes that we want the users to see immediately. So if you change something, I should see this directly. If I manipulate data in one place in my system, this should be propagated to all other places. So if you manipulate the numbers in the chart, the bar chart and pie chart should be immediately updated. So we have a name, we have a bunch of problems, and the next part is the solution. And maybe it does not come as a surprise, but divide the system into 3 packages. The model, data and rules, the business rules. This is exactly the same thing as in the model view separation principle. You have the functionality, the things that fulfill the requirements. The view, this is basically visualization and low-level input. That is input that is platform specific. So if you need to access something that is really dependent on the platform and at a low level, then you should probably put this in the view. I guess if you do the PHP course, you put post and get variables. Access to these are put in view classes. This is an example of, well, the platform is HTTP protocol. We get input from these variables in this protocol, and those are put at the low level in the view. And the controller. This handles interaction, execution of user scenarios. If we have written our requirements in the form of use cases, well, there we often have actually the code for the controller, because the controller often tells the view to present something, collects some information from the view, tells the model to perform something with this information, collects the result from the model, tells the view to, well, okay, here's the new information, visualize it. So we have this, let's say, the controller is like a referee that takes something from the view, puts it in the model, and takes the result from the model and puts it in the view. So he's the middleman. And depending on how advanced your requirements or scenarios are, this can be quite a lot of code actually. Yes, we will take a look at a coding example later on. So we have these 3 parts: the model, the view, and controller packages. This is the basic structure. We should also define a mechanism to let the model inform view and controller about changes. And the third thing is don't let the model be dependent on the view or controller. Just as in the model view separation principle, the model cannot contain any user interface code, and the user interface code now is divided between the view and the controller. So this is not allowed. Can't scroll it. And consequently, we cannot put data or rules in the view or controller. So if we have functionality that belongs into the model, this should not leak out into the view or controller. Just as in the model view separation principle. So let's take a new sheet here, I think. What do we get when we apply this pattern then? We get a lot of consequences. Maybe that's how we spell it. We can have this. We can have multiple user interfaces that use the same rules and data. And this solves, of course, a lot of our problems with different users have different needs. We need to have different support for different platforms, and we want this the ability to visualize the same data in different ways. Just as in the circle example, we had could imagine that, well, of course, in this first application, we wanted the graphical user interface and we wanted circles visualized on the screen in some way. But in other applications, then maybe we want these to be visualized in different ways. So this is something that is good. We can synchronize our user interfaces. Synchronization of user interfaces. This is good. We can change and evolve our user interfaces better, because it is not the end of the world that we add an experiment user interface, test that out, and collect feedback from the users, and maybe we should go with this new user interface, maybe we should not. The model view controller is quite framework friendly. Do you know what a framework is? You probably have used frameworks that maybe have had a model view controller architecture, or at least intended to have. Frameworks are exciting because they don't only reuse design, and they don't only reuse code, so they are on a higher level than an API or a design pattern. They kind of like reuse both design and code at the same time. So you get some code, and then you plug in your specific classes or modules or what it is, and then into this designed framework, and they are supposed to work in some way. And we have a lot of frameworks that use the model view controller pattern. It's quite test friendly. It becomes much easier to test, especially the model. If you're careful, you can also probably automate testing for your controller. Views are notoriously hard to test automatically because they are about visualizing something, and well, you often need a person sitting at the computer and looking at it, and okay, I can click this button, and I see the information I should see. So views are probably hard to test, but both model and controller, and that is quite some code there, becomes easier to test than if you mix it all up. Reuse. If you're careful when you write your views, you can reuse them in whole or part at least. So if you are really good at writing views, you can reuse them. Model classes are maybe the more classical example of reuse. So you should be able to take some of the model classes and reuse them for other implementations and put other user interfaces on them. Another advantage is we have a nice mapping of requirements to design to code, because our controllers implement the scenarios we have. So in the controllers, you often find quite literally how the scenario looks actually in the requirement. And this makes, of course, debugging and finding problems easier, because if you know where the user was when the error occurred, you should be able to find the controller quite fast, and from the controller you can trace out to, well, okay, this functionality was used in the view, this functionality was used in the model, and well, the error should be located to either of these parts of the code. And maybe you even have, well, in this step, there was an error. So you can go back, look in the controller, well, okay, this if statement was executed, and well, these parts were executed in the view and the model. So we have a nice mapping of requirements to design to code. And this is something that is quite good. I will just do the liabilities also. Well, everything is well, you have some good parts and you have some bad parts, of course. There is a tendency that controller view becomes very bound to the model, and this makes it hard to reuse them, of course. You can be a little bit more careful, especially when writing your views, but this is often hard and can put costs extra in time of work and effort to make your views really model independent. Yes, we can have a little bit better maintainability, and that is probably what I mean with this mapping of requirement to design to code. It becomes easier to maintain, for example, if you find an error. And also, well, we need to change and evolve our user interface. So this is also something that has to do with maintainability. Performance is something that often comes up, and it has at least a possible performance hit, depending on how you design this chain propagation mechanism. You can have something that is called update storms. That is, the application or system becomes trapped in updating really many user interfaces, and maybe the change was really small and changes come very frequently, and sending an update for every little change can become cumbersome, and the application as such may not respond as well as it should. This depends in some ways on how you design this. Maybe you design it at a very high level. Well, the model just tells the user interface that, well, something has changed. And the user interface needs to check the model and go down into classes and check, okay, what is it that changed actually? And to finally find out, well, okay, I'm not visualizing this, so all this processing was a waste. Or you could design this interface to be very finely tuned and say exactly this has changed in this situation. But then again, you probably get quite a complicated interface here. Many functions, many ways of notifying the user interface, detailed parameters and such. And that becomes a burden when coding or when evolving the model. So it is not easy to find a good balance there. The main source of confusion in my experience is that no one really knows what the controller is. And this is also something that is interpreted in different ways, in different frameworks, and over time we have had different interpretation of, well, what the heck is the controller and what is the view? How should we separate these? And basically the basic pattern says quite little about this. Almost everyone understands the model user interface separation. Okay, I see very few errors from students that put user interface in the model. It happens, but it's often quite hidden and sometimes open for interpretation. But the main confusion is about the view and the controller. And the description of the pattern really does not help us very much. So when deciding for the model view controller pattern, you need to take a look at this. How are we in our project going to separate the view and the controller? Are we putting these types of classes, these types of responsibilities in the controller? Are we putting others in the view? And finding a good balance there is not that easy. It is very easy to have really fat views that has a lot of information and state inside them. It's also really easy to get really thin views and fat controllers that holds a lot of state for interaction. And finding a good balance there is not that easy. Sometimes you kind of like make the model classes user interface specific, and not by adding user interface code into them, but rather that they serve as a special kind of user interface. And they kind of like have functionality that is tailored towards this interaction. And I return data that is really formatted or convenient for this type of user interface. And this adds complexity to the model, unnecessary complexity. So you should always be on the lookout for this. Is this function actually something that is used in the model itself, or is it just a service function for the user interface to get some data in a particular format? Getting sorted data, for example. Okay, I want to get all the the customers in our database, I want them sorted on their customer ID. Should we add a separate function for this in the model? Get sorted customers. Or should we just add a function called get customers, and then it's up to the user interface to sort them in the way it wants? These are more interesting questions, actually. Should we add complexity to the model, or should we push complexity to the user interface? This pattern has a lot of different names, a lot of different variations on kind of like the same theme. And, well, you need to look out, and maybe someone uses some other name but actually means this. And over time, there has been a lot of differences here, and I will actually link you to a paper that describes them. And what they basically are, they tend to focus on the view and the controller, and have, well, this pattern that we are calling model view presenter instead. Well, then we have the scenarios in the controller. If we do the view model view pattern, that is basically the same thing. We have another little bit more specific interpretation of the model view controller. And we have supervising controllers, and we have passive view, and we have, well, there are a lot of different things. They tend to focus on how to structure the view and the controller, and how the relationships between the view and controller and the model are handled. We get the question here. That can be extremely inefficient, though, if you are using a large database. A database is constructed to do that. A user interface is not usually good at sorting a large amount of data. Exactly. Might be pretty code, but bad performance. Exactly. This is what makes things hard and interesting. You need to kind of like decide. This also maybe depends on what type of database you are using. Maybe you're not using a SQL database that is really good at getting sorted data, but you're using a document-based database instead. So it is not, I can't give you any simple answers. There is no silver bullet solution. You should always do this, or you should always do that. But you should be aware of the decisions you make and the consequences of them. So if we decide to put this functionality in the model, this getting sorted customers or whatnot, we add complexity into the model. But maybe we gain performance if we put it in the user interface. When maybe we get a more evenly distributed complexity and better maintenance, but maybe we have a little bit of performance hit. At the same time, you could also argue that, well, maybe the database server, it's really a bottleneck in our system. We have lots of users, and if everyone is going to access the database and get sorted customers, that will decrease performance on the database. If we instead can do a simpler query and push this responsibility to a JavaScript on each client, because that is faster, well, then maybe sorting should be in the user interface instead. So there are no one solution fits all. So you need to be aware of your actions and your options. And basically what you need to do is, well, we need to test. We need to test this under realistic circumstances. Questions so far? No? We will take a look at the basic structure and then call it like example after the break, but 15 minutes of a break.